When I'm given an equation that has the same base on either side, all I have to worry about is making the exponents the same. So in this case, my base is e. Because it's the same base on either side, let's just ignore it. And all I have to do is make sure that 5, the exponent on the left, is equal to negative 2x plus 11, the exponent on the right. So even though this equation might look complicated, all I have to worry about is solving this linear equation. So if I subtract 11 from both sides, I get negative 6 equal to negative 2x, and then of course x must come out to be 3. It's that simple. I could check this the same way I would check any equation by plugging 3 back in for x. So if I look back in my exponent, negative 2 times 3 is negative 6. And if I add 11 to that, I end up with 5. So both sides are e to the 5th. On the other example, I want to make sure that I only have a single base on either side. And so to do this, I'll have to combine some bases using my exponent rules. Hopefully you recall these from previous classes. Because I have the same base being multiplied, my exponents are going to add together. In this case, I do have like terms, so I can add x plus 2x to get 3x. If they weren't like terms, I would just add up like I would always do. On the right-hand side of this equation, then, I've got a power raised to a power. The rule in that case was to multiply those exponents together. And in this particular example, make sure you distribute as well. So e will get an exponent of negative 3x. And then minus 3. And so now, just like the first example we took a look at, I have the same base on either side. So because the base is already the same, I don't need to worry about that. I just have to worry about making my exponents equal to each other. So 3x has to be equal to negative 3x minus 3. Now your 3x's don't cancel out because they're not the same thing on either side. I'll add 3x to both sides, so I get 6x equals negative 3. And then dividing by 6 gets me an x value of negative 1/2.